Dear students, welcome to Loksatta. I'm sure you're reading all the articles which are published in Loksatta Yashasvi Bhava regularly. At the same time, go through this all videos which are going to be put up on YouTube also. Last year you have learned circle in detail. You have learned about circle, its definition, the chord of the circle, the properties, the theorems. So before you start studying the circle chapter in standard 10 textbook, make sure you go through 9th standard textbook and go through all the theorems which are given in the 9th standard textbook, because many of the 9th standard theorems which are given in the textbook, you also need them in your standard 10. Let us see what is the previous knowledge you required for the chapter circle. As you can see here, in 9th standard you have chapter on quadrilateral, in which they have given various properties of quadrilateral. When you start studying the standard 10 syllabus, then as you start solving the sums one after another, there are various properties of quadrilateral you require in them. For example, in one of the exercises, you have to prove a quadrilateral as a square. So in such cases, first we prove quadrilateral as a rectangle by using property if each angle is 90 degree, the quadrilateral is a rectangle, and then we prove the same quadrilateral as a square by using rectangle with adjacent sides congruent is a square. So all the properties of quadrilateral are very, very important. Just go through them again because you need them in standard 10 also. Then we have two theorems from standard 9, isosceles triangle theorem and converse of isosceles triangle theorem. Please make sure that what is the difference between the converse of isosceles triangle theorem and isosceles triangle theorem. If it is not clear, again open the book of standard 9 and make sure you get the correction correctly. Then we have remote interior angle theorem. Always there is a mistake between remote interior angle theorem and exterior angle theorem. Exterior angle theorem we use when we are talking about something called as inequality, and when we talk about remote interior angle theorem, which is equal to the measure of exterior angle is equal to sum of the measures of remote interior angles. So again, if you are not clear, then open the book of standard 9 and get the things clear. Then we have two theorems on locus in standard 9 textbook. One is perpendicular bisector theorem and the second one is angle bisector theorem. Then we have in the circle lesson of standard 9th, there are various theorems are given, various properties also given. Go through them and by heart all the statements of the theorem, because you have to write them as a reason whenever you are solving the problem. For example, perpendicular drawn from the center of the circle bisect the chord, and the converse of it is segment joining the center of the circle and the midpoint of the chord is perpendicular to it. So both the theorems you should know at the same time by heart the statements, because you need them to write as a reason whenever you need them in any particular sum, even in standard 10th also. Then there are various properties of diameter given. For example, diameter subtends right angle at any point on the circle other than the end points, and the converse of it, if the segment subtends right angle at any point on the circle, then the segment is the diameter of a circle. Diameter is the longest chord of the circle. So many properties are given about diameter in standard 9 textbook. Again, revise them because we need them in standard 10 also. Then we have different measure of the arcs which are given in the textbook. The measure of the arc if the semicircle is given, it is 180 degree. The measure of circle is 360 degree. Then something is called as definition of measure of minor arc. It means the measure of a central angle is equal to the measure of corresponding minor arcs. Now all these properties along with some more properties which are given in standard 10 textbook, not only given in the chapter circle, but in the chapters which are given like quadrilateral, triangles. Please revise it, because in circle all these theorems we are going to use when we are going to study one by one the examples which are given in the exercise. So before you start your 10th standard syllabus, especially the chapter circle, make sure you clear your basic knowledge, or you go to your basics and make sure that your basic is absolutely clear. Okay, let us study two examples in which we are using the theorems which are given in standard 9 textbook. Just now I told you one theorem about perpendicular drawn from the center of the circle bisect the chord, which is given in standard 9 textbook. if you have the textbook in front of you, you see the exercise 2.1 sum number 4, in which there are two concentric circles are given and a chord AB is given, which is tangent to the smaller circle with center O. We have to prove that T is a midpoint of segment AB. We can prove this particular sum by using this particular theorem. Now how to prove it? Step number 1. In smaller circle, center is O and OT is a radius, whereas segment AB is a tangent. So according to the theorem, tangent is perpendicular to radius. At point of contact, we have angle OTB, which is 90 degree. Correct? Now you take example of take a bigger circle. In bigger circle, segment OT is perpendicular to chord AB, and according to this theorem, perpendicular drawn from the center of the circle to any chord bisect the chord. So according to this theorem, we will get AT is equal to TB. It means that T is a midpoint of segment AB, reason A dash C dash B. Now, as I've already told you, you can solve sum by any logically correct method or technically correct method. The same sum you can also solve by using test of congruency. But if you use the theorem which are given in standard 9, you reduce the number of steps also. Let us take one more example about the same. Last year we have learned about perpendicular bisector theorem. Now if you have a textbook, you open it and see exercise 2.1 sum number 2. Now in this particular sum, we have to prove that segment OD is perpendicular bisector of segment AC. Now as we know that first we have BC is equal to BA. The reason is the length of tangent segment drawn from the external point to the circle are equal. At the same time we have OC is equal to OA, reason radii of the same circle. So now if I apply the perpendicular bisector theorem, then what do I get? I will get point B is equidistant from the endpoints of segment AC. Point B lies on perpendicular bisector of segment AC, reason perpendicular bisector theorem. Same way, O is equidistant from the endpoints of segment AC. Therefore, point O lies on perpendicular bisector of segment AC. Again, the reason is same, perpendicular bisector theorem. From statement 1 and 2, what do we get? We get we get OB is perpendicular bisector of segment AC. That is nothing but segment OD is perpendicular bisector of segment AC, reason O dash D dash B. Again, in this case, you can prove the same. OD is perpendicular bisector of segment AC by using the test of congruency. But if you know the theorem of perpendicular bisector, your number of steps are reduced, right? And it will save your time also. So any method which is you are convenient, you solve by that method. But make sure your previous knowledge, which is given in standard 9 textbook, is correct. If it is not, go back to standard 9, get your doubts clear, and then come back to standard 10 syllabus. Okay, let us take example of the other theorem, which is if a line is perpendicular to one of the two parallel lines, then it is also perpendicular to other. The example is problem set, example number 1. In this diagram, what is given? That chord AB is parallel to CD. The value of AB is given. We have to find the radius of the circle. Now, we'll first use this theorem, but the tangent is perpendicular to radius at point of contact. Using this theorem, we can prove angle POC is 90 degree. Now, already we have AB is parallel to CD and angle POC is 90 degree. So, according to this theorem, if a line is perpendicular to one of the two parallel lines, it is also perpendicular to other. So angle AMP is also becomes 90 degree. The theorem is if a line is perpendicular to one of the two parallel lines, it is also perpendicular to other. If not, you can use corresponding angles, converse of corresponding angles test. By using that also we can prove angle AMP 90 degree. After this, assume the radius of the circle as x. If AP is x, then PO will be also x. As we know that M is the midpoint of segment PO, so PM will become as x upon 2, and then by using Pythagoras theorem, we can find the value of x. So in this case, we have used the theorem which is given in 9th textbook, which says that if a line is perpendicular to one of the two parallel lines, it is also perpendicular to other. If we don't want to use this theorem, you will use the converse of corresponding angle test. Again, that is also given in standard 9 textbook. So it is very important that you make sure you go to the standard 9 textbook and make sure that your all doubts are clear before you start studying the standard 10 textbook. Okay, let us study a few more examples from problem set. We have problem set sum number 7, in which we have quadrilateral ABCD is a cyclic and angle ABC is congruent to angle BCD. We have to prove two things. One is seg AD is parallel to BC, and second thing is side DC is congruent to side AB. Now your construction is draw segment BD. Now here we are going to use one of the theorems from standard 9 textbook, which says that in same circle the congruent arcs have congruent chords. First we prove AD is parallel to BC by using interior angle test. Again, you have learned in standard 9 textbook. You can see over here quadrilateral ABCD is a cyclic quadrilateral, and the theorem which is given in your textbook says that in cyclic quadrilateral opposite angles are supplementary. So we have angle ABC plus angle ADC is equal to 180 degree. At the same time we have angle ABC is congruent to angle BDC. So what do we get here? We get major angle BCD plus major angle ADC is equal to 180 degree. Now these two angles are interior angles, and the interior angles are supplementary. The AD and BC will become parallel by interior angle test. Okay. So first we will prove AD is parallel to BC. After proving AD is parallel to BC by using interior angle test, now we are going to use again the theorem which is given in standard 9. That is nothing but segment AD is parallel to BC, and if your transversal is AD, then angle ADB is congruent to angle CBD. These are alternate angles, or you can write converse of alternate angle test or parallel lines AD, BC and transversal BD. After proving these two angles congruent, we will use theorem which is given in standard 10 textbook, that is inscribe angle theorem. Angle ADB is equal to half of major arc AB, and angle CBD is equal to half of major arc DC. These are inscribe angle theorem. As these two angles are equal, you will get half of major arc AB is equal to half of major arc DC, and if I cancel half from both the sides, or if I multiply both the sides by 2, I will get arc AB which is equal to arc BC, and then I will apply this theorem. If in the same circle, if arcs are congruent, then their corresponding chords are also congruent. So if arc AB is equal to arc DC, then using this theorem we will get AB is equal to DC. The reason, in same circle congruent chords have congruent arcs. In other example that is given in the problem set, which is sum number 21, in which we are going to use two theorems. One is the midpoint theorem, and the other property which is given in textbook, that is in the right angle triangle, median drawn to hypotenuse is half of the hypotenuse. As you can see in the diagram, PQR are the midpoints of sides AB, AC and BC respectively. We have to prove that quadrilateral quadrilateral PQRS is a cyclic. First we will use midpoint theorem. In triangle ABC, P is the midpoint of AB, Q is the midpoint of AC. So by midpoint theorem we will get PQ is equal to half of BC, and we will get PQ is parallel to BC. Now in quadrilateral PBRQ, we have PQ is parallel to BR. At the same time PQ is half of BC, which is nothing but half of BC is BR. So we get PQ is equal to BR. Therefore quadrilateral PBRQ will become a parallelogram if the reason is if one pair of opposite sides are parallel and congruent, then the quadrilateral is a parallelogram. After proving this quadrilateral as a parallelogram, we will write that opposite angles of parallelogram are congruent. So you have angle B is congruent to angle Q. Then in triangle ASB, angle ASB is 90 degree and segment SP is median to hypotenuse AB. So we can use this theorem in right angle triangle. Median drawn to hypotenuse is half of the hypotenuse. You will get SP is equal to half of AB. Now half of AB is nothing but PB. So what we get is PB is equal to PS. And if PB is equal to PS, the triangle PBS will become a isosceles triangle. And according to isosceles triangle theorem, we will get angle PBS is congruent to angle PSB. Right? So here is a good example that we have used both the theorems of midpoint theorem, and in right angle triangle the median drawn to hypotenuse is half of the hypotenuse. Now after this we know that angle PSB is the exterior angle of quadrilateral PQRS. Now we know that angle PBS is congruent to angle PQR, but PBS is congruent to PSB. So what do we get is PSB is congruent to PQR. Okay, so if PSB is congruent to PQR, then according to the theorem which is given in the textbook, if the exterior angle of quadrilateral is congruent to angle opposite to interior adjacent angle, then the quadrilateral will become a cyclic. So using that theorem we can prove quadrilateral PQRS as a cyclic quadrilateral. Okay, now from all these examples we can conclude that before you start studying the circle lesson of standard 10 or even the similarity, make sure your 9th standard basics are pretty much clear. If not, you go back to standard 9 textbook. Now after this, in the next lecture, we are going to see what are the mistakes done by the students in respect to the lesson circle. So I'm sure that you are not going to make those mistakes in exam when you're writing the answers, or when you are going to appear for your SSC examination.